In this section, we're looking at a trigonometric form of a complex number. If you recall, a complex number can be written in the form of a plus bi, where a is our real part and the bi is our imaginary part. Now, just like a real number can be represented on a rectangular coordinate plane, we can represent our complex number on a complex plane. On our complex plane, the equivalent of our x-axis is a real axis, and the equivalent of our y-axis is an imaginary axis. So a number in the form of a plus bi can be represented here, with a being our first coordinate on the real axis, and b being the second coordinate on the imaginary axis. For example, if we have a complex number such as 3 plus 2i, this could theoretically be a point here with coordinates 3, 2, where 3 is the value on the real axis and 2 is the value on the imaginary axis. To find the absolute value of a complex number, the absolute value of a complex number is the square root of a squared plus b squared. Since the absolute value is defined as a distance from a point, we can use our distance formula. And here you can see, by using the distance formula, we get the distance from 0 to the point. So here's an example of plotting complex number and finding their absolute value. First, we're given the complex number negative 7i. So to find the absolute value of negative 7i, we can see that our real part is 0. So this will be negative 7 squared, our imaginary part, squared plus 0 squared. So this is square root of 49, which is just 7. Here the imaginary part, the bi, is 0. So our b is equal to 0. So the absolute value of negative 7 plus bi would be negative 7 squared plus 0 squared, and the square root of that is 7. So we can see even from this that the absolute value of negative 7 is also 7. The absolute value of negative 8 plus 3i would be negative 8 all squared plus 3 all squared, which is 64 plus 9, and that's 73. So this comes out to be the square root of 73. Now to plot these, the negative 7i, so this would be on our imaginary axis since there's no real part. So if this is negative 5i and 10i, 7i would be somewhere here. So this is a positive 7, negative, sorry. So negative 7i would be down here. And negative 7 on our real axis would be somewhere over here. So this would be negative 7. And here we have negative 8 and a positive 3i. So this is negative 7, negative 8 approximately here, and 3i maybe here. So here we have negative 8 plus 3i, or just negative 8 and 3. So here we have found the absolute value of these three complex numbers, and we've also plot them on our complex plane. Once again, we're looking at a trigonometric form of a complex number. Just now we plotted points of a complex number in the form of a plus bi. Now, if we draw a line segment from our origin to our point AB, then we measure our angle theta from the real axis to our line segment. We get a distance here which we can call r. And now we have theoretically a right triangle, and this side is equivalent to the adjacent side, which is a distance, and this is our opposite side of theta, which is b. From this triangle we can see that a, from our cosine rule, a is equal to r cosine theta, since cosine of theta is equal to a over r. So a is equal to r cosine theta. We know that sine of theta is equal to b over r, so b will be equal to r times sine theta. Now if we substitute for a and b in our complex number, we know that a is equal to r cosine theta, and that b is equal to r sine theta. So this becomes r cosine theta plus r sine theta times I. If we factor out the r, we have r times cosine theta plus I sine theta. And this is the trigonometric form of a complex number. Now to find r, using Pythagorean theorem again, r is equal to the square root of a squared plus b squared, since this is a right triangle. And from our identity for tan, we know tan is equal to opposite over adjacent, so tan of theta is equal to b over a. In this example, we're going to graph a complex number and write it in its trigonometric form. Here we're given the complex number -7 plus 4i. So graphing this, we have -7 on our real axis, and we have the 4 on our imaginary axis. So here's the point, -7, 4i for our complex. So we have graphed the complex number -7 plus 4i. We can see that the line segment from the point to the circle gives us an angle of theta from our real axis here. To find theta, we first need to find theta prime. We know that tan of theta prime is equal to b over a. So this would be our b and this would be our a, which is -4/7. So the theta prime will be equal to the tan inverse of -4/7, which is approximately 29.7 degrees. Now because this is in our second quadrant, when we find theta prime, we have to take it away or subtract it from 180 degrees to find our angle theta, which is what we're really interested in. So angle theta will be equal to 180 minus 29.7 degrees, which gives us 150.3. So our angle theta is 153.3 degrees. Now to find r, we know r is equal to the square root of a squared plus b squared. So this is -7 squared plus 4 squared. So that's 49 plus 16, which is 65. So this is equal to the square root of 65. Now we know in the trigonometric form, r is equal to the square r times cosine theta plus I sine theta. So this is going to be square root of 65 cosine 150.3 degrees plus I sine 150 degrees. So it's actually z is equal to that. Here we're given a complex number in its trigonometric form, and we are being required to write it in standard form and then graph it. So here's our complex number, 2 times the cosine of 60 plus I times the sine of 60. So to rewrite this in standard form, we convert cosine of 60 to its standard form, and we know that cosine of 60 is 1/2, and that the sine of 60 is square root of 3/2. So this becomes 2 times 1/2 plus I times the square root of 3/2. If we distribute our 2 to both of these, the 2 will cancel, so this leaves us at 1 plus the square root of 3 times I. So here's our complex number in its standard form, the form of a plus bi, where a is equal to 1 and b is equal to the square root of 3. Now we need to graph this. So our a is a positive 1 and our b is a positive square root of 3. So we have 1, the square root of 3 is approximately 1.7. So here we have graphically our complex number 1 plus the square root of 3 times I. Now one of the advantages of having a complex number in the trigonometric form is in the multiplication and division of complex numbers. Here, if we have a complex number z1 in its complex form, which is r1 times cosine theta 1 plus I times sine theta 1, and we have a second complex number z2 equaling r2 times cosine theta 2 plus I times sine theta 2, their product would be equal to r1 times r2, here a bracket, times cosine of theta 1 plus theta 2 plus I sine theta 1 theta 2. So here all we're going to do is find the sum of the angles, and we still find the cosine and the sine, and we multiply r1 times r2. In division, it's very similar to the multiplication, except we're going to subtract our angles and we're going to divide R1 by R2. So to divide Z1 by Z2, that'll be equal to R1 divided by R2 times cosine of theta 1 minus theta 2 plus I times sine theta 1 minus theta 2. Here we'll be looking at an example of multiplying and dividing a complex number in its trigonometric form. In our first part, we have the multiplication of two complex numbers. So here we have 3/4 times the cosine of pi by 3 plus I sine of pi by 3. And this is our first complex number, and this is times 4 cosine of 3 pi by 4 plus I sine of 3 pi by 4. So all of this here is our Z1 and all of this is our Z2. So here we have our two complex number. From our formula for a complex number, we multiply R1 times R2. So this is 3/4 times 4, which will simplify to give us 3. And then it's a cosine of theta 1 plus theta 2, so it becomes the cosine of pi by 3 plus 3 pi by 4, which gives us 13 pi by 12. So same thing for sine, pi by 3 plus 3 pi by 4. So our final answer for this product is 3 times the cosine of 13 pi by 12 plus I sine of 13 pi by 12. For division, here we have our Z1 on top and our Z2 on the bottom. So Z1 is 12 cosine of 92 plus I sine of 92. Our Z2 is 2 cosine of 122 plus I sine of 122. If you recall, for division, when we divide, we're going to divide our R1 divided by R2. So 12 divided by 2 is 6. Then it's a cosine of theta 1 minus theta 2. So this is 92 minus 122, which just give us negative 30. So here we have 6 cosine of negative 30 plus I sine of negative 30 degrees. We recall from our unit circle that negative 30 is the same thing as 300 degrees. So we can rewrite this as 6 cosine of 330 degrees plus I sine of 330 degrees.